Welcome in, everybody, for today's show. We have a special guest today. His name is Mr. Earth Guy, and you probably know him from TikTok. He's always there, either debating or shooting at videos about geology and things like that. So, welcome in, Mr. Earth Guy. How are you?
I'm doing really well, thanks. Thanks for having me on. I know we've sort of had these discussions over the last, several
Yeah,
weeks in terms of when we're going to get this thing, on the road. But yeah, we're finally here, and I'm excited to sort of have this discussion.
yeah, and this is your, I think your third time on the on my YouTube. But welcome
Yes.
back.
Yeah. No, no, thank you. Looking
Yeah.
forward to it.
So today we want to talk about human evolution and perhaps geological factors, climatic factors that have changed our evolution. And we're going to have a good discussion, very organic discussion today. So first, tell us a bit about yourself so the audience understand who you are and what you're all about.
Yeah. So as you rightly mentioned, I'm Mr. Earth Guy. I sort of I say I'm a geologist and slash earth geoscientist. Academically, I was trained as a geologist, but then ventured into the more niche hydrocarbon side of the industry. So as a consequence, I've learned about different ways that the earth works from a natural sense in terms of the usual geological stuff that most people will learn in their schools, either through geology or through other subjects like chemistry and then geography and physics and things like that. But then, due to my sort of background in petroleum geosciences, a lot of study has been done in the subsurface and understanding how the subsurface works and the influences and the impacts on petroleum generation and things like that. Um, I started my sort of geoscience communication journey 3 or 4 years ago now on TikTok, and yeah, I probably release between 5 to 6 videos a week, sometimes more, sometimes less. But I try to create videos which are engaging, that have a technical source, but alter that in a way that people can understand. Because there's lots of knowledge hidden in scientific literature, and sometimes it's the language which is the problem or the barrier for people reading it and learning. So my mission,
Right.
if you will, is to break down those walls of technical words, technical jargon, things like that, and just share with people.
Yeah, you do a good job out on that for sure. Yeah, so thanks for sharing that. I actually have a geoscience degree as well. I have, as you probably know, I've done a bit of research there as well in college. Cool. Sounds good. So, human evolution. A lot of people love to talk about this. I love to talk about human evolution. I love to talk about our past. Um, in terms of our evolution, what kind of separates us from the other apes? What were the geological factors that really, changed our species and made us evolve into who we are as humans?
So that's a very large question.
Yeah,
I
very
think
broad.
it's probably best to probably try and break this down into um, the fundamentals of why evolution happens from a geological perspective, so that we get an understanding of what those processes may be. Obviously, we always speak about natural selection, and obviously natural selective pressures have many sort of components as to what can selectively, make a species speciate or turn it, branch off into another species. Geologically speaking, there's a huge impact, right? So we can talk about the isolation effect. So over time, Earth has shifted its continents, land masses have grown or been destroyed, flooding events, sea level changes, fluctuations, climate variability, things like that. And unfortunately, nature itself is rather weak in the grand scheme of the powerful forces that shape the earth, right? So when the sea levels rise, life has no ability to sort of combat that, at least not until our present way of life, where we can put dams and we can change the morphology of the land a bit. But throughout Earth's history, when we've had sort of climatic events in different sort of degrees, life has just had to make do with what's changed, right? And that's not like isolated to just humans. It's all life itself, and it's one of the propellants as to why we've diversified in the way we have. If we so the geographic isolation is obviously a very key part there. It separates the gene pool because it means they can no longer connect with each other. If we're talking about one species or a family or the phylum or the king. It depends on obviously how large the isolation extent was. That's just one factor that can influence natural selection. Another one is climate variability, and that again has some sort of impacts on the global sort of plate structure of the Earth. When we speak about the Earth's place in the solar system, for example, we have the Milankovitch cycles, and that sort of the way the Earth, where the Earth is at any one point in time around the sun, and that is they have cycles. So we have precession, eccentricity. So eccentricity is sort of the distance of the orbit away from the sun. Obliquity is the wobble that we have, and precession is the tilt. And those have different effects, whether how much sunlight is achieved that reaches the surface, or solar radiation, ice ages, things like that. So geologically, there are many, many, many factors that influence evolution as a whole, right? And it's interesting that obviously today we're going to speak about the human side of it, and potentially how different geological events, at least in the last 3 to 4 million years, may have influenced not just the splitting up of hominids, but potentially like cranial size, the ability for
Mm.
bipedalism, how, what could have influenced those factors. And there's some really interesting papers that have been released that sort of really dive down into those details, which I hope we can sort of at least touch on in the discussion today.
Yeah, for sure. So, for those of you who are listening, the Earth wobbles on its axis. The distance between it and the sun changes, and in other words, its orbital period changes through cycles, different time periods, millions of years. Some are thousands of years, like the Milankovitch cycles. But the point is that there's a change in this orbit, and that changes how much energy we receive from the sun, the potency of it, and that changes the climate. I also think, isn't it true that there's like um, radiation from outer space that can actually potentially affect the climate as well?
It can, yes, but I would say it would be minimal compared to our proximity to the sun, which is the
Yeah.
dominant input giver, if you will, of energy to our semi-closed. I don't like to say Earth is a closed system because it's nothing's a closed system in that sense, but there's always an external factor that can influence the Earth, and 9 times out of 10, it's solar radiation. But as we know, 66 billion years ago, other things could come and really mess
Right.
things up. So,
Yeah.
but solar radiation is the most dominant in terms of its impacts on evolution and life itself.
Right. Now, humans, we began, well, it's a long story, but in Africa, there were apes about 20 million years ago, and those have slowly evolved to our common ship ancestors about 9, 10 million years ago. And from there, we diverged. Is that correct?
Uh, yes, I think the some of the earliest. I'm gonna really butcher this name here, but it's I've got it written down because I knew I wouldn't be able to say it myself. But I think the earliest fossil record that we have was of a genre called Sahelanthropus oronin. That is one of, and that's again, I'm reading that. I'm going to be playing there because I don't know Latin, but that's one of the earliest fossils that we have. We talk about these like stages of evolution. Then we have like Australopithecus, and then we have obviously then we have the branching off into Homo, which occurred around sort of the Pleistocene time, so between 2.5 to 3 million years ago. And then since then, it then branched off into all our subspecies, and there's dozens of them, but like Heidelbergensis and Erectus, and we got Sapiens, and we got Floresiensis. There are many different types. And funny enough, I think today's discussion, it would be really interesting to sort of dive in onto the Homo side of where obviously we're the Sapiens, right? But there's a key set of like geological periods or impacts that, and I don't mean impacts from like a meteorite impact. I meant like more like climatic impacts that sort of coincidentally mark very tight, like strict, like divergences and
Mm.
migrations of when Heidelbergensis came about, or where Erectus came about, or where Sapiens came about. And whilst the evidence, you can't ever be like 100% conclusive. That's not what science is, right? It's about always finding new data to back up hypotheses that we have, or to make better understandings of the world around us. They really tell a really compelling story of wetting periods and drying periods in relation to whether an entire group migrated away or they dispersed because of, oh, we'll get into it, but that's sort of a little teaser of the kind of stuff we'll talk about. But
Right, right.
yeah.
Yeah, I wanna kinda start from the beginning of, like, what really separated us, from, like, some of the first steps. Um, so as you guys probably may know, we actually share a common ancestry with chimps and all the other apes of today about 10 million years ago. And from there, we were living our ancestors were living mostly in trees, right? They were in trees, and then for some reason, we left the trees, right? What isn't in like in Africa, but maybe like 6 million years ago, there was like a climatic shift in the plains of Africa,
Yeah.
and that kind of
So
forced us out of the trees.
yeah. So one of the main, so I think it's known as the variability hypothesis. It talks about the climatic variations that there are several hypotheses that are out there, but there are a few which explain this sort of transitional shift, right? So as you mentioned, we the anatomical evidence that we have of really our sort of ancestors says, okay, well, they sort of match up and they align with the analogs of today, the animals and the apes that live in trees, like that sort of structure. So that's conclusive enough to say that those humans must have also, or those pre-humans, proto-humans, they would have lived or at least dwelled in the trees for most of their time because they have this, the anatomical structures that sort of resonate with today's analogs. But there are um, the east. We let's speak like geographically here, like the East Rift Valley, sort of where we have the cradle of humanity. That is sort of where we associate sort of the dawn of our species, right? Interestingly, it's interesting that that's the place. So if we're going to speak geology, it's interesting that place is where things started to diverge and change. Um, Geologically speaking, I think it started somewhere between 40 to 60 million years ago. So that we've got the southern east part of Africa is like slowly splitting away, and geologically that makes some really interesting changes to the environment. Um, but it obviously the separating of any landmass, it brings more energy to the system. So volcanics, lava flows, the thinning of the crust, so the heat of the ground changes, the groundwater changes, that influences the vegetation, it influences loads of things. So
Mm,
and that's usually the case when it comes to these evolutionary sort of key markers. They usually occur in places where there's acute change. It's one example I can give beyond humans is to sort of the Miyako Islands, which are south of Japan. They are an island chain that once were connected by land masses. After we came out the glacial periods, the sea level rose. It split off the islands from each other, sort of like the Galapagos. These are like the Japanese equivalent, and then a new endemic species was formed. So that's a very acute event. It's a short period of time. Something drastic happens, and that's what we can say about the East African Rift Valley. It's a place of dynamic change. Massive basins have been formed, and basins are really important, right? Because basins act as sinks. It's where lots of rivers, lots of waterfalls, lots of water collects. So um, but in turn, this also means that the weather patterns change. When something as big as the Rift Valley occur, weather patterns change. And when I mean weather, I mean like microclimates. I'm not talking about the entirety of Africa.
mm,
We do have like microclimates that exist on continents, depending on mountain ranges and basins that are forming. And at that particular time, where we saw the change between tree livers, forest dwellers, if you will, down to savanna. That move from a forest to a savanna. We saw it magically it ties in with the precession cycles, so the wobbles, so the things that happen every 26,000 years in the Milankovitch cycles. Um, there was this massive fluctuation between aridity and wetness, and as a consequence, um, in periods where when you compile the aridity and the wetness with the extension of the rift, so that the breaking apart, the movement of the rift of the East Rift Valley, it made very prolonged periods of arid environments, which aren't obviously favorable to forests. So one of the conclusions you can make is the precession, so the wobble effect of the Earth, along with the movement of the East Rift Valley, it it may have forced our ancestors that were once living in lush green forests and that sort of lifestyle, well, all of a sudden the environment's changing and the forests are scaling back, the forests are thinning, so they're
Mm.
losing their homes, they're losing their habitat. So they may have been forced to move to a more savanna based environment, which in turn may have also influenced that bipedalism, that need to, if we can't just live in forests and if we have tailbones and things like that, um, if we can't use all four of our limbs and we have to live on the floor, then there are two limbs which are going to be more important than most, and they are our legs. So
Right.
there's that conversation to have whether the change in variance between the forest, so that sort of nice humid climatic sort of weather that you get in the tropics, to a more savanna base with grasslands and things like that, whether that had influence on not just us coming out of trees, but also the influence on us using more of our legs.
Yeah, and while we were in the trees, when we still were able to use 2 legs to travel, but it was less efficient. We had more hunched backs, and we had pretty much, like, graspable feet, right?
Yes,
It's
yes,
just like
yes.
we had graspable, fingers. But the point is that we are mainly used to trees, and then when we were forced to leave the trees over
Yeah.
many generations, mind you, we the ones who used their legs the most, the bipedalism, because that was the most efficient way of traversing the plains of Africa,
Mhm, mhm.
finding new habitats, finding new water sources, right? So this also probably had a lot to do with the brain growth or brain development.
Yeah. One of the things that I was going to mention as well is, obviously we're just talking about um, sort of the start of all hominids were bipedal, right? Our
Right.
Heidelbergensis erectus. We're talking about the start, but especially with cranial growth, those wet periods and dry periods were essential for the dispersal patterns, right? Because we always talk about how the out of Africa hypothesis, and where why was it the sapiens that decided to go out and not necessarily everyone else? Like what were those driving factors that did that, and why did some do more than others? And there's always been this consensus, like, okay, could it have been that was just how they evolved? They evolved to be more nomadic and venture out. They never settled down, in quotations. But geologically speaking, we do see evidence again through the precession cycles, those sort of 26,000 year cycles, along with eccentricity. So the longer period, so the 100,000 year cycle, which is the orbital parameters, which influence things like glaciation and ice ages.
Mm,
Of all the cycles, it's the precession cycles which normally influence the ice ages and the glaciation periods every 100,000 years. We see it through the Pleistocene, the Pliocene. Every 100,000 years, there are these sort of glacial occurrences which match the eccentricity. Um, but the interesting thing here is the 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 evidence for the cranial. We sort of see in the record that the cranial growth started to occur. Like, I think Erectus had quite a large brain compared to its ancestor, um, and they match with the occurrence of deep water lakes in the rift valleys of of Africa. So, for example, and rift valleys and basins with lots of lakes, that implies very wet conditions. So the climate has shifted from being an arid environment to a wet environment. Now you could say, okay, well, why would that matter, right? Why would brain growth matter? Well, more wet environments usually have life can sustain better in wetter environments compared to really arid environments. So
mm,
the more nutrition, more resources can help, right? Um, it also means that the hominids they didn't necessarily have to think about survival all the time. Now, that's not to say that surviving wasn't important, because of course it was. But as you can imagine, if food's more available, water, which is our vital is vital for life, if that's more readily available, then their brains can be used for other things that don't
mm,
necessarily require them to just have to think about, well, where am I going to get the next watering hole from, right? There's a big lake there, I can have water from the lake. So the
mm,
idea is there may have been some influence there, that having these during these wet periods, uh, humans, or the hominids, they could use their brains for other things that allowed them to start growing. And obviously, with more nutrition and more food comes more energy and growth as a consequence. Like the brain is like, in terms of mass, it uses 25% of all the energy in our bodies. So it's one of the highest like absorb like nutrient sort of intaking organ that we have. So our brains require lots of food, lots of energy, and lots of nutrition. So
Right.
it makes sense that brains and cranial capacities were growing in periods where there would have been surplus amounts of water, surplus amounts of food.
Yeah, I think the brain takes like 20% today, or today's brains takes about like
It is.
20% of our energy. So
Yeah.
it's just incredible. But yeah, so what we have is a species who is already, well, not a species, but a population of apes who were
Yeah.
already predisposed to being relatively smart in the trees,
Mhm.
but because they were very social animals. And then they left the trees, and now they were exposed to new environments, weather conditions. They were exposed to less trees and more sparse trees, but different habitats and different water sources, different food sources, and then fire. Right? Doesn't fire come along soon after that?
Yeah. So importantly, the okay. So fire. There are two parts. Two ways you can think about it. Right? Is when we associate ourselves with fire, you either it's warmth or it's cooking. Right? There's
Mm.
some of the two
Yeah.
ways that you can think about fire. And obviously, it can be used to ward off predators, and fire's
Yeah.
not fire harnessing the power of fire isn't natural in the natural world, right? I mean, sure, fires happen, but some being holding a wooden stick with fire on it and doing what it wants with it, that's harnessing the power of fire. So but in essence, you would think, okay, fire would have been good for heating. So in periods of cooling, so when we think about
Mm.
those glacial periods, so during the Pleistocene and Pliocene, there are these variable uh, conditions of cold, dry, sometimes arid. Like arid doesn't necessarily mean hot, right? Arid is just bare and barren. It can be the same way Antarctica is an arid. It's
Mm.
arid, right? In terms of it's bare and there's nothing there. There's no life. Um, so in these circumstances where obviously the Earth is still in an ice age, and back then it was still in an ice age. These interglacial periods would have been influenced by the Milankovitch cycles, and yeah, the idea that fire may have been obviously we can't necessarily speak to like what went through whatever the being's mind was to start thinking about how, was it flint, was it an accident, was it lightning and you got a stick, or I don't think science will ever be able to exactly tell you what the first occurrence of fire was.
Mm.
Obviously if you find archaeological evidence of flint and certain things, and we know that they might have used those tools to create fires, especially if it's like charred deposits or charred fossils. um but in essence, one of the reasons why fire may have been something was to keep warm during these glacial periods when they were forced out of their tropical environments, and then suddenly they've got to go into the more open, savanna barren
Mm.
environments and expose themselves to the elements. Um, Fire may have been a really good way for them to um, keep themselves warm, but obviously it also allows them to cook food, and cooking food makes it last longer. So if there are periods of, um, you know, uh, as we mentioned before, like the wettability versus arid, by cooking your food, it lasts longer. It means you can take it with you. So if the idea of walking and that nomad lifestyle, fire would have been essential for that.
Right, and in this period, we were kind of traversing throughout Northern Africa, correct? We were traversing out of Africa that way, beginning
Yeah,
to move
so,
out.
yeah, towards the north, but also to the south. It's important to
Mm.
realize that, like,
Mm.
South Africa has a very, very some of the oldest hominid bones we've ever found are in South Africa. So that it's like, it wasn't just an up and down, it was an outwards movement, right? We always see
Mm.
those cartoons of, like, the arrows going up towards
Yeah,
Egypt
yeah,
and then across,
yeah,
but
that's yeah,
yeah,
that's
yeah. I mean, that's a great way to sort of show the overall direction of like where sapiens went, for example.
right.
They sort of evolved and then they sort of dispersed upwards north. But it's important to know that they also went down to South Africa. We have some really old caves and old cave paintings in South Africa of the
Mm.
humans there. Um, but but yes, in general, they were moving upwards, and that again links with there are some really nice climatic models that have been done through like pollen grain analysis and core samples of the lakes I was talking about in the Rift Valley, where you can sort of get these, you can sort of see the climate shifting where um, the dry periods were intensifying, they were sort of prolonging, and as a consequence, the most successful of the evolved species of hominids, the sapiens, they were sort of being pushed. So in dry periods, they dispersed, they migrated away completely, right? In the wet periods, they naturally grew bigger and expanded because they were doing well. Does that make sense?
Mm,
So
right,
when you
and you have a combination of these things, and it's like a
yes,
compound.
exactly.
Wow,
Because the wet periods weren't turmoil and harshness. It was like, okay, well, we're doing good. Colonies getting bigger. We can expand a bit. We can move further out. So that's still migration. It's just still migrating and pushing the boundaries of your existence.
right,
But in the more barren, arid conditions where it was harder to survive, they're the acute triggers natural pressures that will push a species of hominid to go further and further and further up. So
right.
yeah, so in essence, during those time periods, we as I spoke about the deep lakes and the arid periods, um, there was the sapiens. The sapiens are the ones that pushed out during these drying episodes. They're the ones that went further. We were built better to walk, built better to run. We were built better
Mm,
to move. So we're the ones that took the initiative and said, you know, we're going to start wandering and migrating upwards towards where eventually, um, you know, to the Mesopotamian region. I know we're fast forwarding a lot there, but you know, if it wasn't for those like dry periods, which allowed which forced sapiens to go up, the cradle of humanity, so the Fertile Crescent, where you know eventually civilization started in the Mesopotamian region, that probably wouldn't have happened, right? Because those dry periods are so important.
yeah, so in this time, just summarize,
Yeah,
basically, leave the trees, there's wedding giant cycles, we're forced to grow, expand outwards. In the process, we develop new ways of, walking, new ways of, um, fire and all these different resources that actually enable us to become for our brains to develop and grow larger. In the process, we are likely discovering some of the first religions, maybe some like some
yeah,
of the first tribes.
maybe. Yeah, I was gonna say religions. I don't think the idea of religion would have probably come until much later. But rituals is probably
Rituals, yeah.
yeah. I'd say rituals because whether they had any um reason behind they did a certain thing. Like when I think of religion, I think of like it's a set of bounding principles that
Yeah,
is
yeah.
created, right? Whereas a ritual,
The
it may just be
proto
yeah,
religions,
the
maybe.
proto religions. Yeah, it's
Mhm.
it's that the you know, oh, we did something and something good happened. Maybe if we
Right,
keep doing that same thing, it might continue to have good things, and it becomes a ritual. And then next thing you know,
right.
everyone's doing it because it's
Habits,
just yeah,
yeah,
yeah, exactly.
these
Yeah,
habits that become inherited,
it's like the
and
whole
then
like you sneeze or you have a not sneeze, but when you what is it? When you hope for the best and you touch wood. Like why do you touch wood? Like it's a
yeah,
weird thing, but it's like a ritualistic thing we've learned to do because it's been passed down
yeah,
for
and
generations.
this is probably around this time is where that really started,
Probably,
and
yeah.
then
The yeah,
as we built fire and closer tribes, more social, areas. And then during this time, there were probably different several species of humans that also emerged in this migration, and that's what and sapiens happen to be the ones who expanded the most, right? So
yes,
during this
yes.
time, how many species of humans were there that were like sapiens?
Um, there were off the top of my head, I probably don't know an exact number, but we do know that there was an overlap. So obviously we think that we came like our evolutionary sort of predecessor was Heidelbergensis, but there was Erectus, there was um but it's important to know that the migrations, I think from what I've read and what I've learned is that it wasn't this sort of linear thing, right? It wasn't
Mhm.
like we know, for example, like Neanderthals from Heidelbergensis, they evolved separately in Europe in the high latitude regions. Erectus, for example, they were all over anyway. They were quite a global species, Erectus. They weren't just
Mm.
localized to one area. So different species of hominid or it's probably important to mention like maybe there were subspecies because there's still debate as to which ones could mate with each other and which ones
Yeah,
could like call them separate species. We're assuming that's gone now, but
yeah,
there are so many interlapping inter
looping and
overlocking,
overlapping.
looping,
Yeah,
overlapping um migratory patterns of all these species. We keep finding new ones in different areas. Like, wait a minute, we didn't know it was there.
yeah,
And then you date where the time periods are on the rocks or the stuff they were using. You're like, wait a minute, these guys are. these guys are at the same time period as the Denisovans or the
Right.
Floresiensis, and it's like, okay, well, maybe we need to we need to rework our calendar and who was interacting with who. But I mean, off the top of my head, I would say between that I know of five or six different other variants that we had. But I'm sure if you spoke to an evolutionary biologist, they'd be like, "Oh no, there were at least 15."
Yeah, no, that's really, really complex how we evolved because again, our brains were complex as just as being human. So of course, I think wasn't like half a million years ago or even a million years ago, we were a global like there were humans all around the globe, right?
Yeah, I think North America was one of the later continents to because
Yeah,
of
yeah.
the
Like
bridge
North
between
America.
Africa, sorry, Alaska and Russia. But yeah, apart from North America, and as a consequence, I suppose South America,
A lot
because
of
they
humans
were
were in yeah, a lot of
yeah,
humans were in East Asia, Southeast Asia,
yes, yes,
and
yes,
those islands in Europe. Europe was a really dense
yeah.
place
Yeah,
with lots of humans.
and there would have been loads of conflict, and I think geologically speaking, since we're sort of talking from that lens, is the it would have been really interesting. Obviously, during the Pleistocene, the sort of northern latitudes of our Earth were quite cold and temperate, um, and obviously Neanderthals were better. They evolved into those conditions a lot better than, let's say, sapiens or um,
Yeah, so
uh,
what about sapiens made us so different and special?
so I would say for us, well, Neanderthals were a lot more rigid. So, for example, they had fused like metatarsals and thumbs, for example, like from some of the fossils that we've seen, like which meant that they probably found it more difficult holding tools, not tools, but like spears and things like that. So I mean,
Ooh.
if you think about it, if I can hold an object and use it in a more I can use it in a more versatile way,
Right.
then I would also be able to outdo my opponents. And similarly, we were more lean. Our skeletal structures we were more lean. So we probably were a lot quicker. Our stamina was probably better. But that's not to say that everyone always thinks as Neanderthals as being like these cavemen, right? We always get all these big like cavemen looking things
Yeah.
with beards and this. Like Neanderthals had bigger brains than sapiens did at the time, right?
Yeah,
Their
yeah,
cranial capacities were bigger. They were larger.
yeah.
So it's one of those where brains doesn't always or physical it's the physique versus the brain. Which one's going to win, right? Is it the smarter one or is it the more beefy one? And I think a lot of people make the misconception that the Neanderthals were the beefy, strong, Hercules-looking ones, and us sapiens were like this lean, like like
Yeah.
me. I'm just like this little like stick, right? But Neanderthals are very smart, and there's evidence to show as well that they were ritualistic. They had also the evidence of charring with charcoal and fire. They also had all of these things. It wasn't just sapiens that did this. Now the question you can say is whether there was enough intermixing between Neanderthals and sapiens that this knowledge was shared and passed around. Um, Off the top of my head, I can't pinpoint the order in which the charred sort of deposits and the charred sort of fire deposits were found, whether it was sapiens first, then Neanderthals, or vice versa, or around the same time period. But there is evidence for communal gatherings amongst the Neanderthals and the sapiens.
Wow,
Um, so
wow.
so much so that at one point they thought it was a conflict, but um, there's other hypotheses that suggest that we bred them out of existence, right? So, like, because
Yeah.
we all do have Neanderthal, not all of us, but a lot of people around the world have Neanderthal DNA if they have linkages to Europe or
Mm,
Eurasia. So we do know that we interbred with Neanderthals. So the
right.
question is was it tension through aggressive means that killed off the Neanderthals, or was it aggression through other means that killed
Mhm.
off the Neanderthals?
Yeah, that's really interesting. And, now during this time, it was just Neanderthals and sapiens. Were there any other species existing with them?
We had the Denisovans. But they were more. The Denisovans were a bit further
East.
east. Yeah, we have evidence that they were around at that time. And as I mentioned before, Erectus has always been around and chilling, but they sort of died out as well. But they were a global. I can quickly just make sure get an ancestral tree up for you. I won't share it, but I think it might be interesting just to sort of see the layovers and crossovers of the different species at any one piece in time.
Yeah, I mean, you can share it if you want, but you can on the screen if you want to.
Well,
Um,
we can talk about it, but maybe if you're making this
yeah, yeah,
for your YouTube, you can sort of bring it up rather than me having me in
yeah.
this small little screen here.
Okay. Um, then the next thing I want to talk about after that is perhaps when the first civilizations emerged,
Yeah,
farming. Talk about like animism, things like that.
yeah,
That
of
really
course.
began the first religions, and then we can go from there.
Yeah.
Um,
So just to quickly interject, on the record, sapiens, Neanderthals, and Heidelbergensis, they sort of overlapped, but in like a way that Heidelbergensis sort of overlapped with Neanderthals,
mhm,
and they branched off where Neanderthal, sapien, but there was a point where they were together. But
mm,
they died naturally as we know with evolution. It doesn't there's not this is the debate we always have with people that don't believe in evolution. It's like, oh well, was one to the next. It's like, well, no, there's always going to be an overlap. There's always going to
right,
be an overlap.
right.
Um, unless Europe split in half, as we spoke about, it isolated, which obviously didn't happen in that time period. But Erectus was also around when we had Heidelbergensis. So
Wow.
there was Erectus. If I put them in order, Erectus, Heidelbergensis with them, and then we had Neanderthal up here, and we had Sapien here. So Heidelbergensis was actually a very resilient
Mm,
predecessor to us. It was there for a very, very, very long time. According to
mm.
this, it's somewhere between nearly a million years, of it as a
Existed.
species
Wow.
before it went on to do other things like become us.
Yeah, that's amazing. And then like 20,000 years, maybe 20,000, 30,000 years ago, and I've heard evidence that perhaps even 50,000 years ago, we migrated into North America and South America.
Yes, yeah, I think hands up my knowledge on the North American sort of migrations of the hominids across from the the passage called there's a passage that
Bering
connects
Strait.
the Bering Strait. That's the one. Yeah. In terms of my knowledge exactly when they came in, but no, what you're saying I've heard as well, but I've not read it personally. I've just heard it through nice conversations I've had with archaeologists and fellow friends that are passionate about this. So
Yeah, I think
yeah.
yeah, I think they found like footprints or mud
Mm.
prints of human feet and dates like 40,000, 30,000 years ago.
Yeah, was that
Um,
the white sands? Was it the white sands? I feel like the whole there's like a child and parent footprints that are
mm,
in one of the national parks in America, and it shows a really crazy story of the saber-toothed tiger and um a mother or a father and a child, and it's the story of this animal, and it's all recorded in footprints in America. It's absolutely fascinating. Like
that's
again,
cool.
it's kind of geology, but I can't
Yeah,
remember the exact paper off the top of my head. But whoever's listening, if you want to know, go to the White Sands, and it these footprints tell a story of how a family ran away and then came back when they were safe, and a predator chasing them. It was really really interesting.
yeah, that's amazing. That reminds me of there were actually saber-toothed tigers existing with humans and all kinds of mammoths and amazing animals. But for those of you guys who don't know, today's world, there's the Bering Strait. There's really just ocean, but and thousands of years ago, there was cold enough up north for there to be an ice bridge that would be snow and ice that would collect above the water, allow people to walk across it in other words, from Siberia and Russia to Americas and Canada and Southern America. And that's really where the Mayans came in. Well, that's thousands of years after that, but the point is that some civilizations began shortly after that. Um, yeah. So is that anything else you want to add about that?
Um, I think getting onto the story of the dawn of civilization, it's probably important to sort of provide some context as to why it started where it did.
Mm,
Um, obviously we speak about so we're really fast forwarding now, right? From sort of like the branching off of the species, but um going towards and I think it's important we do talk about sort of the Neolithic and the Stone Age and across the world we have different structures that started to appear and the idea that religion played a part. So but just before we talk about that, it's just sort of setting the scene, like geologically speaking, of the Fertile Crescent, which is where if we were to define civilization, so the idea of the first city or civilization, or we agree that it was in the Mesopotamian region. I think Tel Abu Herrera is a very fine example of one of the first repetitive single area dwellings where even after a cataclysm or after flooding events, they still rebuilt there because that was their home. That they didn't move away
Mhm.
and make something else. They kept rebuilding on this tell, as they call it.
Yeah.
And one of the important things is, and I know religious scriptures talk about these two rivers all the time, but the Euphrates and the Tigris, right? So the Fertile Crescent is uniquely positioned in that area because we have the Arabian Plate, which is the peninsula which has Saudi Arabia, Yemen, Oman, and you know the UAE. That sort of Arabian Peninsula, which has the Red Sea that connects between Africa and the Arabian Peninsula, that is pushing up into Europe and Asia, right? And as a consequence, you have this really chaotic fault zone area, and Turkey sits on that. That's why Turkey gets all these earthquakes, and they're going to get all those earthquakes. It's sort of the Arabian Plate is pushing up and rotating around into Eurasia and pushing Turkey towards into Europe. That's why Turkey has all of those earthquakes, and they will have more earthquakes. But there's loads and loads of faults in that region, and
Mhm.
as a consequence, it pushed when a plate pushes another plate. You get like mountainous regions, like for Iraq and Iran, they have like nice mountain ranges, and
Mhm.
lots of mountains and the Kurdish regions and things like that. Um, as a consequence of that, you get what is known as a foreland basin. So it's just basin that sort of like it's like a depression that sits next to the plate. And in foreland basins is where you normally get lots of big rivers because it's a depression area amongst a lot of high
Mhm.
area. So
Mhm.
the Euphrates and the Tigris they fit within that foreland basin because the Arabian plate's pushed up. It's created a depression, and the rivers flow through that. So and those rivers are really really important because their flooding events, their periodic flooding events, is what makes the area so fertile. And
Mhm.
it's the mountain building event that brings up all the nutrients and all of the minerals out of the igneous and the metamorphic rocks that feed the river that allow that area to be really fertile.
Wow.
So when they hear of the
Okay.
Fertile Crescent, it links back to the rivers, which links back to the mountains and the geology as a consequence of the Arabian Plate moving. So the idea that civilization sort of started there was geologically because it was the prime place for these rivers to bring lots of mineral rich nutrients, nice big vast floodplain. So if they're farming and agriculture and things like that,
Right.
there wasn't a better place to do it than there, basically, at that time.
Yeah, wow. So you have like diverse array of environmental conditions.
Yeah.
Plus, because it's not a tropical area, in Mesopotamia, it's by the way, it's near modern day Jordan
Jordan,
area,
Syria,
Syria.
that sort of Jordan, Syria, that sort of Middle Eastern area right there is where
Right.
modern day Mesopotamia
And the
is.
climate is, I guess, pretty cold during the winter time and pretty
Yeah, it's
decent in the summertime. So the point is that there's a in terms of farming, that's a good climate you wanna be in, one where there's versatility there.
yeah,
You want
yeah.
to be able to have different types of crops growing in certain times. Um,
Exactly.
yeah.
Even though there's more evidence to show like it was um well it's two ways, right? Is the diversity of the kind of stuff, whether it was more barley rich or wheat or oats and things like that, it or wheat primarily because it's resilience to you can grow it in many places, right? There are certain crops
Mhm.
which are harder to grow in certain areas, or they need lots of rainfall and things like that. And at that time they hadn't developed irrigation, right? Some of the
Mm.
first irrigation would have been in places like Mohenjo-daro in the Indus Valley civilization in India, where current Pakistan and India is. They're some of the earliest civilizations, which was about 6,000-ish years ago, that had plumbing and irrigation
Hmm.
There's evidence for that. So, but we're talking like 12,000, 14,000 years ago, right? So the idea that they could control the amount of water that was coming in the land off the river, the Tigris and the Euphrates, it wasn't quite there yet. They were probably relying on the cyclic nature of the flooding and the drying of the Euphrates as a consequence.
Right.
So yeah, but you're 100% right. Is a place to plant anything, it would have been a really, really good place to do that. And fallen basins are normally quite flat as well. They're like low depressions, so it's not like they would be like mountainous or lots of hills like what China did with their terraces in the hills. They didn't have to do any of that stuff because it was quite
Mhm.
nice and flat and yeah.
Good. Yeah. So, okay. So it's a good area for them to settle. Um, the Mesopotamians, did they have their own religions? Did they have their own
So go
astronomy and things like that?
Going, if you're talking again, we're not talking about present day Mesopotamia when we speak about these ancient civilizations. Obviously, like Tel Abu Herrera, for example, there was evidence of farming, there was evidence of family, of bonding. There was like little fossilized evidence of repetitive building in the same area. So there was obviously a settlement there. But interestingly, obviously we've all, I hope, or maybe some people have heard about the younger Dryas sort of impact hypothesis, which sort of changed the climate for a while. And funny enough, Tel Abu Herrera was one of the few places where one of the fragments of the asteroid came and exploded above the Tel. So there's
Mm,
actually asteroid evidence of the shards and shocked quartz above and baked in the stonework of the foundations of Tel Abu Herrera. So not only is it a place that may have started civilization, but 12 to 13,000 years ago, when the younger Dryas meteorite came in, poor guys, they were in the way of it as well. So that reset them. But guess what? They still rebuilt there afterwards. It just showed how important that Fertile Crescent land was to them. Um,
yeah, and that event probably sparked a lot of like different spiritual beliefs and things. Like, oh, there's a god coming down, and
I have no doubt about that, and I think that sort of nicely falls into sort of the religion part of
yeah,
evolution. And I think it's important that it's probably worth us speaking from a more holistic point by touching on different civilizations and what they've done. Um, and then maybe the transition of how, as you mentioned before, like the animism, and then it went to like idols, or it's
mhm,
interesting, right? How things have changed over time, right?
yeah,
There's whether you're looking at like sort of the Neolithic or the Mesolithic, like, sort of man with like Stonehenge in the UK, and we've got loads of like causeways and barrow structures that all imply that they had some sort of belief system, like um and at the same time they thought geology was really important. Like, for example, Stonehenge, obviously the infamous sort of circles that are in the south of England, like some of the rocks were quarried from nearby granite quarries, but they obviously thought like their religious beliefs were really important, to the point where they went 300 miles away to get bluestone schists from Wales and brought them down the river Avon uh, to put in that structure. So they went
wow,
300 miles away to get one type of schist metamorphic stone. It's called bluestone, but
yeah,
it's not really blue. It's blue if you cut into it and put water on it. It's a bit of a hue there. But they brought those bluestones and put them the inner ring, and then the altar stone. There's evidence to show that that stone doesn't exist anywhere in south of England. The only place that stone exists is in
wow,
the north in Scotland, so over 450 miles away. So
wow,
they obviously even back in like Stone Age man, if you will, they had some sort of like pull of how important a belief was, that they
yeah,
didn't just use what was around them. They mean they could have used the stone quarries from down the road as they did for the big stones, but no, they knew that as you got closer and closer to the inner ring, where the summer solstice hits through the stone and it hits the altar, that stone needs to be special. It needs to
yeah,
be um
yeah, unique and valuable.
unique and valuable, and it means something. And I think that's a really important sort of part to talk about. Is obviously they thought the sun was really important, right? It was made to have some sort of worship, or some sort of alignment with the fact that the summer solstice is here, and obviously that means something. Now, obviously, we know what the summer solstice means. It's sort of the point.
Yeah.
It's the point where that was it. The sun is it the closest, or it's the shortest day. It's the longest day. Sorry, so it's where the sun is the.
Well, it's when the days are the same. The days are the same.
Yeah,
The
yeah. Sorry, yeah. I'm
the
just
days
talking
and
about
night are the
the.
same amount of
That's
hours.
that's the one. That's the one. It's right in the middle. It's right at the midpoint from when the sun. So that must mean it's the closest then. Is that right? Is my physics off
Well,
there?
there's different solstices during the year, but winter, summer, fall.
Yeah, yeah.
But
Of course, of
the
course.
the the, the point is that even back then they saw that, I mean, from their perspectives, these people, they looked at the sun, the moon, they didn't know what these things were. They didn't know what the solstice was. They didn't know what geology was. They didn't know how these things happen or how stones were produced. So from their perspective, you have to remember that they thought like there was like they could have imagined all kinds of things and stories that try to explain all these amazing things. And it's very amazing because they saw things as more pure than we do today. We kind of just neglect it and we just take it for granted. But then they were like, wow, these stones, these blue stones, we have to go all this way to get there. And we kind of inherited this mentality today when we take a look at jewelry and,
Mm-hmm.
people want these special items. And it's just, but the point is that it's part of our nature to do this. But, but this is
I
where
was
it
gonna
all
say,
began.
like, you can't blame them though, can you? Because like they obviously uh well, it still is today, but the sun is super important, right? I mean, it makes sense for our species, at least at the start, to worship or to put all of their power and belief and faith into something that was powerful. And the sun is the life giver. It allows crops to grow. It makes you feel better. It brings warmth.
Mm.
So the idea that the early religions were invested in more celestial, like whether the sun or the moon, or gods of thunder, weather, natural things that couldn't be explained, as you mentioned, right? If they don't have an explanation for it, but it's super powerful, then it deserves to be worshipped. It deserves to be glorified in some form,
Mm.
because we can't explain it, which means it's beyond us. It must be bigger than us. It must be more important than us. Um,
Yeah. Yeah. They revered it. And that's something we should do more often today. Um, we don't we take things for granted today, but yeah. So when it comes to the first religions, were there any other geological events that really drove these beliefs?
Um, I think the idea I wouldn't say any geological events massively in the last 12 to 13,000 years, at least from like a dawn of civilization point of view. Um, Apart from obviously, as we mentioned, acute impact, like whether it's meteorites or whether it's volcanic eruptions or massive earthquakes. I think those are the kind of things that can influence, because they tell a good story, right? It's like you'll have some people who are obviously, as you go back in time, people were more illiterate. They literally relied on storytelling, like, because
Mhm.
everyone could speak in some form, as some better than others, but there's no way one person could write something down and everyone could read it, because not everyone could read, and the idea of written language wasn't until much later. um but if we just think about even present day, like the Maori people or the Polynesian islands, and you have the people that have lived on there, and how their entire lives revolve around the volcanic islands and the Polynesian islands around sort of Australia and beyond, right? Like, even today there are communities and cultures which are deeply intertwined with the islands or the earth that they're part of. And so you
Mm.
can almost sort of use those as an analogy, where volcanic eruptions, earthquakes, tsunamis, floods, um, crazy, storms which lasted days and days and days, because there might have been an El Nino or an El Nino cycle, for example, that was they couldn't explain any of this stuff, right? But all it took was one person who may have been the leader, the alpha, of the tribe, where they in order to keep control and to keep that momentum of their cause, whatever that cause may be. And they happen to live somewhere near Iceland or somewhere if they're in Iceland and it's volcanoes, or if it's Italy and it's volcanoes, or
Yeah.
any of them, or if it's around the Mediterranean, or if it's the Nile, for example, with the delta, and how the flooding events happened, or um, earthquakes in Japan. And I'm just trying to think of all of the areas where natural disasters occur rather frequently, and or if not frequently, when they do occur, they're really powerful.
Mm.
Those kind of acute events can be used to control so many people. Like the gods are the
Yeah.
gods are angry. The gods are angry because see the
Mhm.
volcano. The gods
Yeah.
we have
It'll
to
blow up.
sacrifice somebody, or we have to we have to do something to please the gods, right?
Yeah.
And at one point in time, the sun, or the if it hasn't rained for 6 months, the rain god, or maybe it was the sun god that was responsible, or maybe the rain god and the sun god were having an argument. And there are loads of things that can come from just natural
Yeah, all these stories
activity.
emerged, and a lot of it came from our desires to have a profitable, crop farm, or, you know, we wanted something out of it, so we would ask the gods to give us things,
It was
right?
always selfish. It was always
Yeah.
selfish means. Like, oh,
Yeah,
well, we should worship the sun god because next year we want bountiful harvesting of crops, and we please the sun god, we'll get more wheat. Great. That's how it works.
yeah,
Or,
and I
yeah,
if you wanna stop something bad from happening, like a flood or a volcanic eruption, well, you have to sacrifice something, or do something for
or
that, or
someone.
there's a ritual. Yeah, or someone. And a lot of these cultures, that's why there's probably a lot of flood stories, because
100%, and that's the
cultures live near flood zone, or rivers, and that was the main.
as we've discussed with the Euphrates and Tigris, is
Mm,
every early civilization, if they weren't by an ocean front, like a seafront with the beach or whatever, it was by some sort of river or large river, because water
mm,
is vital for you would never you would and you would never find a big civilization that wasn't close to a water source of some sorts. They had
right,
to be. They
had to
had
be
to be.
water.
Until
Yeah.
until they developed the ways to make wells, until they knew
I
how to
mean,
do
I'm
wells,
drinking
right?
water right now, that's how important it is, right?
Exactly. So the idea of flooding events, yeah, of course, like one of the
Yeah.
largest rebuttals you get for Noah's flood is like, oh well, then why do all civilizations talk about floods? It's like, well, geologically speaking, floods are the most common disaster. They're the most common disaster of all the things
Exactly,
that could happen.
exactly.
Floods are the most common. They happen, and there's a flood happening everywhere at any one point on Earth somewhere. It may not be
Right,
big, but it's happening.
right, exactly. And then they, from there, from the flood stories, they orally pass them down, like the game telephone, they become different, they add stuff to make it more exaggerated, to make it more pronounced. Oh, there was a big flood, and everybody, oh, God was really angry this time, right? And it's obvious to see how all these religions kind of emerged. Wow, that's amazing, though. It's just the story
No,
of
I
our.
agree. I agree. And I think there's beauty, and that's why whenever that's why I for one never have a problem with religion personally, because like I see religion as a literal cognitive development of our species. I feel like I
Mm,
feel without it we wouldn't be here. Now, whether it's right or wrong, or whether it's someone uses it for the wrong reasons and it caused harm, and that's a separate thing for me. When I think about the fundamentals of what religion is, and I don't mean which god or which prophet or which this, I mean the belief system, right? It's that our brain wants to you
yeah.
know believe things because that's how we've developed and evolved. Like um, so I sort of look at it and I see it as quite a beautiful part of our journey as humans. But
Mm,
but there's a difference between what that belief is, and that development in us as like evolutionary speaking, and then how that can be used as a weapon or used as a tool or used
yeah.
that's where it becomes a different conversation completely. It's we're moving out of the, well, why have humans come to do what they do, to how are we going to use what we did for a purpose, and that purpose may be a bad thing, or some sort of cause or whatever.
Yeah, so the point, yeah, so as we evolved, as our brains grew in size and complexity, so did our imaginations.
Or
And
100%.
this is what drove, this is what allowed these ideas to really evolve in some sense. And and that's really I agree with you. Religion is the expression of this imagination, and religion's a great thing, I think.
Yeah.
But
It's
of course, in today's world, it can be used as a vehicle because it kind of like is parasitic to our fear, like the very human things about us that are like our biggest desires, love, relationship, right? So these religions in certain ones can capitalize on that. And
yeah, for a long time, religion is what made us who we are today. I mean, in terms of like its importance for community building, bonding,
yeah.
unity, storytelling, cognitive development, cognitive passing of information. The and that sort of goes back. We never spoke about it, but like the fact that we have grandparents. We're one of the only mammals or even creatures on this planet that have grandparents. No,
Really?
there aren't many animals that have grandparents because the menopause happens, right? And the menopause is beyond that point is where essentially there aren't many animals that go past menopause. They die with it, right?
Yeah. Oh, wow. Okay.
Yeah, they
Oh,
die. They have their menopause and they die, or they die.
wow.
And one of the reasons that they say that we grandparents are one of the hypotheses around it is, well, grandparents, we found grandparents important. Grandparents were important
Mm,
because they're the ones who looked after the children. They're the ones when we were making the civilizations and people farming lifespans.
mm.
It's the and we still do it to this day. Grandparents still look after the kids,
Oh, yeah.
whether you're
No, yeah.
working. That
Wow.
doesn't
I didn't I
happen.
didn't
That doesn't happen anywhere else. Like what animal? Like there aren't many animals that have. Like dolphins do. Dolphins do. There are some other animals that do with who are very tightly bonded. I think elephants do as well. But for most part, no animals get past the menopause in their reproductive stage and their stage of life. And one of the attributes to that is the fact that grandparents evolutionary were important for us as a species to help support, pass on knowledge, pass on wisdom, pass on,
mm.
and all that kind of stuff. They were necessary.
Yeah, it ties in
Um,
with language, most likely.
all of it. I mean, that's why you go
And,
to your elders. You go to your elders, not because they necessarily know how TikTok works or because they know how, so like obviously, but you can learn fundamental life lessons from your
right,
from your
right.
elders. And that no matter what culture you're from, if you go to a 95 year
Ethics,
old who can
morality, yeah.
still a 95-year-old who's still, right, that can speak properly and is in their right mind, you can learn so much from them that your cohort of people around you just will never be able to teach you. And um obviously the the distance between current knowledge and what they know now is there's a big gap between. But go back 1,000 years, 2,000, 3,000, 4,000 years, where the distractions just weren't there, the Netflixes weren't there, the TikToks weren't
Mhm.
there. Like what a teen knew probably didn't know a hell of a lot more than what a grandpa knew, because not much was happening in the technological space, or like you know but yeah, so I think that's just really, I thought to bring that in there, is like how important the grandparents were
That's a good that was a good
in
point.
in that in
And
that story.
yeah, and, I mean, we see it commonly in common themes in different religions. So it's always the elder one that has the knowledge and gives it down to people, and the elder one.
Yeah, and
Um,
it's maybe why we also have this inert respect towards our elders. Like
mm,
I know some of that's cultural. I know there are some cultures where some will always call an elder uncle and auntie, like in Asian culture, like a lot of like Islamic cultures, for example, like your elder, you never call them by their name. It's either their surname or you call them uncle or auntie out of respect because they're elder than you. But regardless of what culture you come from, the older someone is, just the more respect you have for them, because I don't know why, because I do. I don't know. If I see an old man walking down the street, I'm like, you know what? Fair play, man. He made it.
yeah, it's ingrained in our DNA.
And
We
that's
always look up
exactly. And
to
it
it.
comes back. It comes back to the importance of grandparents, of old people, if you
Right.
want.
You're
um,
that guy, so respect your grandma and grandpa.
yeah, just
So,
they've
yeah,
lived around for
so
a while. They've learned a bit.
we've reached about an hour. I
Yep.
just wanna just go last question, just go back into, like, geology, like,
Yeah, yeah, of course.
any really exciting geology news, anything exciting to talk about in your field or anything you've heard?
Um, so yeah, there's a video that I'm doing soon. It's talking, funny enough, about Mesopotamia, but this isn't Mesopotamia from back in the Fertile Crescent days. This is like 1,000 AD, right? So we're pretty recent,
Mm,
relatively speaking. But uh, they're trying to see if there's this new branch of geology that they're trying to put, which is archaeomagnetism. Archaeomagnetism. It's a new branch that they're trying to sort of dive into, which is the study of ancient relics and bricks and things that civilizations have created in the past to try and understand the Earth's magnetic field and its variations over time at a very
wow.
short term level. Like because obviously um, we because and during those time periods where they were making bricks or they were making structures, especially in the last 2 or 3 thousand years, as a consequence, even though bricks aren't natural rock, they still utilize natural materials to make the bricks, right? So there's lots
Mm,
of iron, lots of particles of iron, for example, in bricks that. So what they're trying to do is figure out if this works in Mesopotamia, could this be a brand new field of getting, if not, if the most detailed magnetic variability graph of the last 5, 6, 7,000 years to basically when we can see the first structures that have been built. Because otherwise, we have to rely on sporadic volcanic events, oceanic
mm,
spreading, and they're really expensive ways. Like we can't just keep drilling into the middle of the Pacific to try and get a core sample to just check its magnetic resonance. We have to find better ways to do that. So they're wondering whether the creation of new human-made mortar and bricks and things like that, whether we can use that material to create like a year by year or a decade by decade change of how the
wow.
Earth's magnetic field has changed over time. And initial um, responses show that it fluctuated heavily. So I'm making so it's not groundbreaking geological news, but it's just really exciting to see geologists push the bounds of let's ignore the earth, let's just maybe combine ourselves with a bit of archaeology and see if we can do something interesting. So um
Yeah, that's
I'm going to do
cool.
a bit of research into it and sort of make a video on it once I've concluded everything I've read before I get too far ahead of myself and say something I don't mean.
Cool. Yeah, so yeah, like there's always this cross reference between different sciences, and I love that about science is very people are so willing to work together, and they're all in this endeavor together for the truth and the objective truth.
No, I agree, and that's why thanks for having me on. I know we always have engaging conversations on TikTok, so it's always nice to have a an environment where it's just a discussion where we're not looking at comments and we're not looking at we're trying to it's just an open organic discussion and we see where the
Yeah.
conversation takes us. So I appreciate you for sort of having me on, and I enjoyed the conversation. It was a lot of fun. Um,
Yeah, and yeah, on TikTok, I don't like to debate. I really don't, but I do it because it brings these topics to light, right?
yeah.
I wish I can do like I wish I can discuss this all day, right? But unfortunately, on TikTok, in order to bring people towards these conversations, we need to debate, and makes
Yeah,
people
and
go,
and
"Whoa,
s and
let
and
me think."
sometimes it has to be the polarizing debates. It's the ones
Yeah,
where you've clearly
it's
got a because everyone I mean TikTok even knows it, right? Because they and again this feeds into the evolutionary of the human mind is the
yeah,
idea that we all evolved in different posses, different groups, different civilizations because us as a species we like to feel unified for a common
mm,
goal. That's why hooliganism in sport is such a big thing. Like it makes no logical sense to me why somebody would like risk their life for a football team or a soccer team.
mm,
Like
right,
what how does that but there are some people that they would die by their club. They would,
yeah,
it means that much to them. And it's like so and if that's something as non like for me it means nothing, but to them it means everything. And so that's just one aspect of humans. We've learned to want to be part of a collective, and I think TikTok does that rather well because they've got their battles on live where like no you can be on my team or you can be on your team or my team and your team.
yeah.
So
We love that as
it
humans.
all it all feeds into that narrative that humans like to support one cause or the other. So that's why polarizing debates always do really well because very rarely will you have someone come into a debate that's rather polarizing and sit there and be like, oh, I don't really care about either. They're normally on one side or the
Yeah,
other, and they're
yeah,
rooting for that one person. So that's why those lives do rather well because it's just innate
yeah.
to us as a species.
And yeah, and I love these discussions because it shows us the similarities between our past and today's people today, where like Trumpism and nationalism and like Like you said,
isms.
sports, like, it's so ingrained in us to just, like, want to have one sign, and we fight for that forever. It's like,
Yeah, yeah, and that's
when
been
you look
throughout
back on that, it's,
time.
like, ridiculous, but
Yeah. There's always been command and conquer and territory and mine, mine, mine. We've done that as a species, and the reason why we do it is because it allowed us our species to become as popular and as diverse as it has today. Without those
yeah,
traits, we probably wouldn't be. We could have gone extinct by another species because we weren't that competitive, fierce.
exactly. We didn't
Uh,
fight, yeah, if you don't fight for nothing, you don't got anything, so
exactly. So I have no doubt that all of these weird things that we do today, I'm sure if you thought about them hard enough, you could root them back to certain points in Earth's as a human's evolution, um, to say, okay, well, that makes sense. I get it.
mm,
I get where anxiety comes from. I mean, I don't. It doesn't need to be a thing now, but
right.
it does. It is a thing. But you can imagine once upon a time when you're running away from saber-toothed tigers, or you weren't sure if you'd fall off a branch onto the floor to get eaten. Oh, I would want anxiety then because I want to make sure
Yeah.
that I'm not. Yeah, but anxiety to go and enter a shopping mall, that's a bit of a weird one, but you can see where it comes from. It comes from this.
Yeah, and we've changed so fast, like, socially, that all these the remnants of our evolution are still present, but they feel like they don't fit,
Mm,
and it's interesting to live in this time where we are like this.
agreed.
But, yeah, so thank you so much for being here. I think
Oh,
that's all for today.
not a problem.
I wish we'd go more, but maybe next time we can talk more, go dive even more into it. But yeah, so everybody go please follow Mr. Earth Guy. Go check him out. YouTube, TikTok, whatever. Um, you
All
will
sorts.
not be disappointed in his work and his videos. Anything else you want to add?
Nope, no, that's it. Just again, thank you for hosting, and I always enjoy the stuff you do. And I'll if I don't see you on YouTube, I'll see you on TikTok. And everyone else, welcome to follow me on my journey of geoscience communication. And yeah, just thanks for having me on, Mike. And I guess we'll speak soon.
Sounds good. Thank you for being here. And see you guys. See you next time. Bye bye.